Hi everyone, and welcome to this YouTube channel called Topics in Dynamic Systems and Control. My name is Dr. Jacob Ward. I'm a recent graduate from Auburn University. My goal with this channel is to provide a resource on all things related to system dynamics and control, which will eventually range on videos all the way from people just beginning their undergraduate programs in system dynamics, all the way through master's and PhD students looking to get a better understanding on various topics. Things you can expect in the coming months are some of the following. The first set of videos I plan to release will be a motivation and review of basic differential equations. This is not to be confused with an entire video series explicitly on differential equations, but primarily just a review of the relevant differential equations knowledge you need to be able to understand system dynamics and controls later. This will also include a couple of videos on topics that can sometimes confuse undergraduate students, such as where do the complex exponentials come from that give us sinusoidal responses, and providing a little bit of a deeper dive on topics like that. Additionally, some resources will be provided that show how we numerically solve differential equations along with MATLAB code and examples. The next topic that we'll dive into is the modeling steps for dynamic systems. This will include learning how to provide the full nonlinear derivation for first, second order, and even higher order systems, while most of these videos will focus on first, second order, or reduced order models or systems. The next topic we'll be talking about is time response for first and second order systems. This will be focused more on finding time constants, settling times, and defining what exactly the transient and steady state behavior of dynamic first and order second systems are. From there, we'll dive into frequency response for first and second order systems, which is more focused on how does a system respond when you apply some kind of an oscillatory input. Are there resonant frequencies? Are there damped frequencies? Is a very important aspect of analyzing a dynamic system. Finally, to conclude the undergraduate topics in system dynamics and control, we will do an introduction to LTI control theory. So we'll cover proportional, proportional integral, proportional derivative, all combinations of basic LTI control. We'll also look at state space control, cascaded control, root locus, which are some very, very powerful tools for an undergraduate to have in their tool belt for designing a control system for some dynamic system. Lastly, some of the more advanced topics we'll be discussing on this channel eventually are model predictive control, nonlinear model predictive control, stochastic nonlinear model predictive control, reference governors, control Lyapunov, and control barrier functions. For those somewhat already familiar with these subjects, you'll notice that most of them have to deal with safe control of dynamic systems, which is a particular emphasis of the research I've done over the past few years. However, if as these videos are released, other topics are required, we can certainly talk about those as well. I appreciate you for looking at this channel, and I hope you find the content you need to further your academic career.